Hello and welcome to this short derivation of the quadratic formula. If you are unaware of what the quadratic formula is, it states that if ax squared plus bx plus c is equal to 0 for some constants a, b and c, provided that a is not equal to 0, then the two values of x that satisfy this given equation are x is equal to negative b plus or minus the square root of b squared minus 4ac whole thing divided by 2a. This is the quadratic formula. So let's go and derive this quadratic formula and prove that it is valid. So first I want to discuss, before we go to there, this quadratic formula and why a should not be 0. And can we solve it if a is equal to 0? Well, first let's consider that a equal to 0. If a equal to 0, then all we have on the left hand side is that 0x squared plus bx plus c is equal to 0. 0x squared is just 0, so this whole thing is 0, which means all we have is that bx plus c is equal to 0. We can of course solve this. Taking the c to the other side, we can see that bx is equal to negative c, meaning that x is equal to negative c divided by b. So yes, it is possible to solve if a is equal to 0. The problem with solving for a equal to 0 using the quadratic formula is that we have to divide here by 0. You can see how that might pose an issue. We have to divide by 0. And this is not of course valid. You cannot divide by 0. We need to specifically state that a is not equal to 0, and just note that if a is equal to 0, there is of course a way to prove it. There's of course a way to find the solutions. So now let's go to the case when a is not equal to 0. Ax squared plus bx plus c equal to 0 for a not equal to 0. In this case, in order to derive the values of x, in order to derive the quadratic formula, we follow the following simple method. First, the first step requires a to not be 0, because the very first thing we're going to do is divide everything by a. So dividing everything by a, provided that a is not equal to 0, we get x squared, because remember ax squared divided by a is just x squared, plus b divided by a x plus c divided by a is equal to 0. Because 0 divided by a is equal to 0, provided that a is not equal to 0. So then we have this. The next thing we're going to do is take this c divided by a to the other side. So we get that x squared plus b divided by a x is equal to negative c divided by a. The next thing we're going to do is try to complete the square on the left hand side. If you don't know what completing the square is, it is trying to find this thing, this left side, in terms of some x plus d, sorry, that d looks like an a, x plus d whole thing squared, where d is some constant. So here you might notice, if we have x plus d whole thing squared, we get x squared plus 2dx plus d squared. But on the left side here, there is no constant term of the form d squared. We do not have a constant on the right hand side. We do have an x squared term, that's alright. We have an x squared term here. We have a constant times an x term here. We have constant times an x term here. But we do not have a d squared term here. There is no constant term on the left hand side of this equation. So what we do in completing the square is to simply invent that constant term. We add the constant term and we subtract the constant term. Notice if I write x plus d whole thing squared minus d squared, this is simply x squared plus 2dx. So what we are going to do here is to create this constant term of d squared and then immediately subtract it. So let's do that. Provided that we have the form on the right hand side of this bottom equation which we have here, it would mean that the coefficient of x squared would be equal to 1, which in this case it is, and it would mean that whatever this constant d is, 2 times the value of d would have to be b divided by a. Suppose that's true. Suppose that 2d is equal to b divided by a. This would mean that the constant d is equal to b divided by 2a. So then that means that whatever this d squared we have to subtract in order to get the form on the right, on the left, would have to be d squared, which is b divided by 2a whole thing squared. So what we have to do here is to write this left side as x squared plus b divided by ax plus d squared minus d squared is equal to negative c divided by a, where d is b divided by 2a. So then if we compute d squared is b divided by 2a whole thing squared, b squared is b squared, and 2a whole thing squared is 4a squared. So what we need to do here is to add and subtract a component of b squared divided by 4a squared. If we just do that on the right side here, if we just do that, we can write plus b squared divided by 4a squared and minus b squared divided by 4a squared. I'm going to erase this scratch work and let's figure out what we just did. So here we are adding and subtracting the same exact value, which means we are doing nothing to the actual value of the left hand side. X squared plus b divided by ax is the same as x squared plus b divided by ax plus b squared divided by 4a squared minus b squared divided by 4a squared. So we already know that this part here, this x squared plus b divided by ax plus b squared divided by 4a can be factorized into x plus d whole thing squared. So I apologize, x plus d whole thing squared, and then that extra minus d squared is this factor here. So writing that down, in this case d is b divided by 2a, so therefore these first three terms, x squared plus b divided by ax plus b squared divided by 4a is equal to x plus b divided by 2a whole thing squared. You can try to do x plus b divided by 2a whole thing squared if you want to confirm that that is in fact equal to these three terms here. And then we have an extra minus b squared divided by 4a squared term, which we are going to keep as minus b squared divided by 4a squared, and that whole thing is equal to negative c divided by a. So now let's take this b squared divided by 4a squared term to the right. So then we get x plus b divided by 2a whole thing squared is equal to b squared divided by 4a squared minus c divided by a. So now let's take the common denominator on the right hand side. We have x plus b divided by 2a on the left hand side whole thing squared is equal to, taking the common denominator on the right hand side, we can see if we multiply the top and bottom of c divided by a by 4a, we can get a common denominator of 4a squared. Simply doing that, we get that this is equal to b squared minus 4a times c divided by 4a squared common denominator. So writing that down on the bottom over here, we get x plus b divided by 2a whole thing squared is equal to b squared minus 4a times c whole thing divided by 4a squared. Now taking the square root of both sides, we get that x plus b divided by 2a is equal to either the positive or the negative square root of b squared minus 4ac whole thing divided by 4a squared. Now we're going to do a little funny thing. We're going to distribute the square root among the top and bottom. We're going to distribute the square root among the numerator and the denominator. So then we get that x plus b divided by 2a is equal to the plus or minus square root of b squared minus 4ac divided by the positive or negative square root of 4a squared. So now I want you to see a little thing here. There is a plus or minus in the numerator here and a plus or minus in the denominator here. But this whole thing could only be either plus or minus. So we don't really need two plus or minuses, we just need one. So let's try and figure out how we can get rid of one of the plus or minuses here. So we have b divided by 2a is equal to plus or minus the square root of b squared minus 4ac divided by the square root of a square is equal to the absolute value of the number. In this case, we have the square root of 4a squared, and 4a squared is 2a whole thing squared. So we have on the denominator plus or minus the absolute value of 2a. So that means either the denominator is plus positive 2a or negative 2a. But on the numerator also we have another plus or minus. So in this case, whether the denominator is positive 2a or negative 2a, the numerator is going to compensate for both of those and still give us both of the positive and negative cases. I hope you understood what I meant by that. The saying plus or minus square root of b squared minus 4ac divided by 2a and plus or minus square root of b squared minus 4ac divided by negative 2a are exactly the same thing, because the plus or minus compensates for both the positive case and the negative case. So I actually really don't need to have something like this. I do not need the plus or minus square absolute value of 2a. I could simply just have plus or minus square root of b squared minus 4ac divided by positive 2a. So I'm exactly going to do that. I'm just going to get rid of this plus or minus absolute value of 2a on the denominator, and I'm going to simply write that we have x plus b divided by 2a equal to the plus or minus square root of b squared minus 4ac whole thing divided by just 2a. I hope you all agree with the getting rid of the plus or minus on the denominator, and I hope you agree that it was unnecessary, and whether we had plus on the denominator or minus on the denominator, the plus or minus on the numerator would have given us the same exact values. So now we only have one last step to do. We have to subtract b divided by 2a from both sides. Doing that, we get that x is equal to negative b divided by 2a plus or minus the square root of b squared minus 4ac whole thing divided by 2a. Taking a common denominator here, we can see that x is equal to negative b plus or minus the square root of b squared minus 4ac whole thing divided by the common denominator of 2a. Hence, we have proven the quadratic formula. We have proven that if we have ax squared plus bx plus c is equal to 0 for a, b and c being real numbers, any real number, we're going to keep it as real numbers for now, and we had the condition that a not equal to 0, which means we can divide by a. Then we found that the two possible solutions for x are x is equal to negative b plus or minus the square root of b squared minus 4ac whole thing divided by 2a. Hence, we have proven the quadratic formula. Thank you for watching, and goodbye.